Okay, so let's practice this idea of the first derivative test. So I'm going to start this problem out just like I did the first problem. I'm going to find those intervals of increasing and decreasing. So the first thing I need to do is find my derivative. So f prime of x in this case equals 1/2. And then the derivative of sine is cosine. So this would be minus cosine of x. And then I need to find out when is this equal to 0 or when is it undefined. So there's no situations where that one is undefined, but it could be equal to 0. So let's look at that. This equals 0. So I'm actually going to add cosine to both sides just to get rid of that negative. So then I'm checking to see, okay, when is the cosine of x equal to 1/2? Now, if you don't remember those points on the unit circle, this would be, the front of your book would be really helpful. So I'm just going to go over here and find, okay, so cosine is my x value. So I'm looking for when is cosine 1/2? So there's 1, so at 5/3. And right here is 1 at pi over 3. So I'm looking at pi over 3 and 5 pi over 3. So x equals pi over 3 and x equals 5 pi over 3. Okay, so when I set up my intervals on this one, they gave me an interval to look at. So they're saying only go from 0 up to 2 pi at the most. So if they give me that, I'm no longer going from negative infinity up to positive infinity. I'm only going from 0 to 2 pi. So I'm going to start with 0 here. And that's going to go up to my smallest value out of these. Well, this is 1/3. This is 5/3. So 1/3 is smallest. So pi over 3. And then I'm going to go from pi over 3 up to my next one, which would be 5 pi over 3. Then I'm going to go from 5 pi over 3 up to my largest value, which is 2 pi. So this is kind of like 1 2/3. This is 2. So up to 2 pi. All right, and then the next thing I'm going to do is come up with some test values. So this may be difficult for some people, thinking about what is from in between 0 and pi over 3. But again, your unit circle could help you with that. So if you're looking for what's between 0 and pi over 3, I could pick one of these values. So I'm just going to pick pi over 4, just for fun. So pi over 4, I think a denominator of 4 is easier to deal with. Then I'm looking for, okay, what's between pi over 3 and 5 pi over 3? So pi over 3 and 5 pi over 3. I'm thinking let's go with, how about we just go with pi? So this is like, okay, so I'm thinking this is 1/3 and this is 5/3, right? So 1/3 and this is 1 2/3. Well, between there is 1. So why not just come up with 1 pi? That's like the easiest value, I think. And then between 5 pi over 3 and 2 pi. So back over here, between 5 pi over 3 and 2 pi. So in this section right here, I'm going to go with 7 pi over 4 because 11 pi over 6 seems like a lot of big numbers. So 7 pi over 4, not really big numbers, but you know what I mean. All right, so I'm going to go with 7 pi over 4. All right, so I am plugging these values in to the derivative. So I'm going to go back up right there is where I'm going to plug those in. So remember, this is the sine of f prime of x. So make sure that you know to plug it into that, not the original function, which sometimes gets confusing. Okay, so when I plug that in, let's see what we get here. So we've got 1/2 minus the cosine of pi over 4. And you can use a calculator for this. I'm just going to give what answers I had here. Hold on a second. Okay, so I came up with, this one ends up negative. So check that. And probably the easiest way is to just check it on your calculator. That'd be the quickest. So that means this is a decreasing function then. That means f of x is a decreasing function there. If I plug pi in right there, I end up with a positive value if I plug it in here. So 1/2 minus cosine of pi, that gives me a positive, which is increasing. If I put 1/2 minus cosine of 7 pi over 4, I get decreasing again. All right, so they want me to find relative extrema. So let's go back to that first derivative test idea. So the derivative test tells me, so here's my pi over 3, right? This is the point, that was my critical number that I checked there, and this one was 5 pi over 3. So I want to know what is happening at those points. So this one, it was decreasing first, and then it was increasing. And I'm not sure exactly how much that was happening, but I know this was a negative slope, this was a positive slope. So here has to be a minimum. And then if I'm increasing here and then I'm decreasing here, then this one has to be a maximum point. Okay, now the other thing too though, let me check and make sure, they are wanting an actual point, I believe. So let me check. On this one, no, they're just asking, no, they just wanted the value where that was happening. So they just said there is a relative minimum at x equals pi over 3 and a relative maximum at x equals 5 pi over 3. So you could write it that way. Now I was checking to see, like, do they want the actual point? Like, do they want to know what the minimum is or what the maximum is? And they didn't in this case. They would specifically ask for that, I guess, if they're wanting it. Okay. Let's see here. So the next one, this one, find the relative extrema of this. So I'm going to first find my derivative. So step 1, find your derivative. So I'm going to bring down my 2/3, leave the inside the same, subtract 1 from the exponent, gives me negative 1/3, and then I'm going to take that times the derivative of the inside, which was 2x. So don't forget about your chain rule. And then when I simplify that, it's going to be kind of ugly. I've got a 2 on top and I've got a 2x on top. So I've got 4x all together up there. On bottom, I have a 3. And I have an x squared minus 4 to the 1/3 power. So I really have a cube root of x squared minus 4. And I want to know, so I'm just going to take this away. I want to know, when is this going to equal 0? So, okay, so let's bring this up also. Anytime I have a rational function, I really need to think about what if it was undefined, right? So I need to think about that as well. So let's start out with 0. When would this function equal 0? Well, it's when the top is 0. So if 4x equals 0, that's a problem, or not necessarily a problem, but a weird point on the graph, something interesting is happening there. So x equals 0 is definitely a critical number. The other situation where this could happen is this denominator, because if the denominator is 0, then this is undefined. So when would this part right there be 0? Because if I take the cube root of 0 and then I multiply it by 3, I'm going to get 0. So I'm just going to think about that x squared minus 4. When does that equal 0? Well, that would be when x is either plus or minus 2. So I have 3 critical points that I need to think about on this one. So let's start with this. I'm going to go, there's no interval given to me on this problem, so I'm going to go from negative infinity up to my smallest value, which in this case was negative 2. Then I'm going to go from that one up to the next smallest, which was 0. Then from that one up to the next one, which was 2. That was my last one, so the next one is from 2 up to infinity. All right, now I'm going to pick some test values here. So my test values, I'm going to pick negative 3. That's inside this interval. -1 is inside this interval, so I'm going to use that. +1 is in this one, and 3 is in this one. So I think I'll use those. Okay, now I'm plugging them into the derivative. So when I go back, if I plug in a -3, right, I'm going to plug it into this one because it's just easier for me to see. If I plug a -3 in here, I get a negative on top. If I plug a -3 in here, that would be 9 minus 4, which is positive. So all of this down here would be positive. So I have a negative divided by a positive, which is a negative. Okay, and then if I plug in a -1, this would be negative. If I plug a -1 in here, I'm going to get 1 minus 4, so that's going to be negative. If I cube root a negative, that would be a negative. So I would end up with a negative over a negative, which is a positive. Okay, my next value, if I plug in a 1, I get a positive on top, negative on bottom like I did earlier. So this one ends up negative, which is decreasing. So that was a positive over a negative. If I plug in a 3, I get positive on top, positive on bottom. So that's positive. Okay, so that means I have, if I'm decreasing and then increasing, my first derivative test tells me that this right here is a minimum. And then if I'm increasing and then decreasing, this one would be a maximum. If I'm decreasing and then increasing, this one would be a minimum. So now I need to go through, this one I kind of have to go find my points because I don't know for sure exactly where it happens. So I need to know which of these is my actual minimum, right? So I have relative minimums at these 2 points, but like which one is actually the minimum, right? So I personally would plug those values in and see what I get. So what does that mean? That means I'm going to take my -2. So this is at -2. This one is at 0. This one is at +2. So I would go back into my original function and I would say, what is my y value then? So what is f of -2? What is f of 0? And what is f of +2? This one did not tell me I had to do that, but in my mind I would because I'm checking to see like which of these is actually the minimum, right? Well, if I plug those in, what I find out is they both are, because if I plug -2 right here, squared, that means +4 minus 4 is 0, so I get 0. If I plug 0 in there, I don't really care so much about this one, but if I plug 0 in, I get -4 to the 2/3 power. I'm just going to write it like that because I don't really care so much about that one right now. This one, if I plug 2 in, I also get 0. So I would just say there is a relative minimum at both, I think I would call it -2, 0 and at 2, 0. And then I have a relative maximum at 0, I could make this a little prettier. So if I square this, I get 16. And then if I cube root that, so I'm just going to call it the cube root of 16. Cube root of 16. You could write it like that. Again, though, if it just asked you to find relative extrema, you could say I have a minimum, I have minimums at -2 and 2, and I have a maximum at x equals 0. And you could stop there. All right, last one, example 4. I wanted to make sure I did this one because we've got a quotient rule. So I just wanted to remind you of how to deal with this. So my derivative is low times the derivative of the high minus high d low all over low squared. So I've got x squared squared, which is really x to the 4th. So now I'm going to simplify this. This would be 4x to the 5th minus distribute this and distribute that negative. So be careful there. So this is going to be minus 2x to the 5th and minus 2x all over x to the 4th. So really that means I have 2x to the 5th minus 2x over x to the 4th, which I'm gonna simplify that even more. I'm gonna factor out, first all of these have an x in them. So I'm gonna take one x out of each of them. So that means I have 2x to the 4th minus 2 over x to the 3rd. Technically right now I could factor a 2 out of the top, but it's not really necessary. So a couple of things I need to check. When is it undefined? Undefined. And when is it 0? So anytime you see a rational function, you need to check that undefined situation. So undefined, from the very beginning, if the denominator was 0, it's undefined. So if x were 0, that's a problem. Same thing with once I find the derivative. If that's 0, that's a problem. So that one's already covered. If the numerator is 0, I have a problem also. So that's when 2x to the 4th minus 2 equals 0. So that's when x to the 4th equals, if I add 2 and then divide by 2, that'd be 1. So that could happen if, I kind of feel like I should be factoring that. Okay, so I'm going to take a step back for just a second. Let's factor that just because we've got difference of squares in there. So this could be x squared plus 1, x squared minus 1, right? So I wanted to just bring this up because of this situation right here. If this happens, I get x squared equals -1, which is not an issue for us. We're not going to worry about that. This one, on the other hand, could be plus or minus 1, because if I add 1 to both sides, I get 1, square root it, you get plus or minus 1. Now, it didn't change my answer a lot if I had just kept going, but just wanted to point that out. All right, so here's my critical numbers then. I've got, I have no intervals, so I'm going to go from -infinity up to -1, and then from -1 up to 0, and then from 0 up to 1, and then 1 up to infinity. So that's a lot to check. My test values in this case, I'm going to use -2, -1/2, which I'm not thrilled about, +1/2, and 2, which kind of stinks a little bit that we had to use those fractions, but it's part of it. It's just, you just deal with it and move on. You can use a calculator, so you can take those and plug them in, but use a calculator to do it. So I'm going to plug them into this, which is my most simplified version, with the exception of factoring. I probably should have factored it. So if I plug in -2 here, that's going to become a positive, and it's definitely going to be bigger than 2. So this top is going to be positive. If I plug in -2 in the bottom, that's going to be negative. So that gives me a positive over a negative, which is negative. If I plug in a -1/2, so here's the question. I don't have a calculator nearby, so I'm just going to talk through it. If I plug in -1/2, I'm going to end up with a negative on the bottom for sure, right? Because a -1/2 to the 3rd is still going to be negative. 3 negatives make a negative. If I plug a negative into the top, -1/2, when I take that to the 4th power and then I take it times 2, that's going to make this smaller than this. So when I subtract 2 from it, it's still going to be negative. So a negative divided by a negative would be a positive. Now, if I do that with +1/2, the same thing's going to happen on top, but the bottom is now going to be positive. So this ends up negative altogether. If I plug 2 in, I'm going to end up with all positives, which is increasing. All right, so decreasing and then increasing means I have a minimum here. Increasing, decreasing means I have a maximum there. Decreasing, increasing means I have a minimum here. So I have relative minimums at -1 and 1. So I'm just going to say at x equals -1 and x equals 1, and then a relative maximum at x equals 0. Now again, if they're wanting the points, hopefully you can tell in the directions if they're wanting the actual points, so maybe just check on that. But you could go back and plug this into the function very easily. So if I plug -1 in here, that gives me 1 plus 1, which is 2, over 1 on the bottom. So this point right here is at -1 comma 2. If I plug 1 in here, the same thing's going to happen. So at 1 comma 2. So these are my minimums. If I plug 0 in here, I end up with 0 over 0, which is a very weird point. So that wouldn't happen. So let me check that because I feel like I'm wrong on this one. Let me look real quick. That's because that is going to be, so let me show you what this looks like. Let me show you the graph here. That's going to be an asymptote, right? This situation right here. So that means there's not actually a maximum there. They're telling me where my minimums are. There's no maximum there. So this actually does not work. This maximum is not a thing. So we need to maybe explore that a little bit. One thing that we're going to be doing coming up is checking how to sketch graphs, and you would definitely notice that once you did it. So check that on your problems. Like if I plug this back in here to my original function, that is 0 over 0. That's an indeterminate form. That's definitely an asymptote. So check for things like that. But in this one, I've got 2 relative minimums, and there they are.